I'm going to talk about acid-base neutralization. We're going to do a couple labs, or maybe one lab, I don't know, a few labs that are going to take advantage of this. What's going on is if you take an acid and you react it with a base, and you get the parts, acid and base, in the proper proportions, you are going to always end up with a salt and water. So that's what neutralization is. It's neutralizing the acid with the base or vice versa. So an example of this, real simple example, would be hydrochloric acid plus sodium hydroxide, OH, going together to form the salt. When I talk about salt, I'm referring to an ionic compound. So an ionic compound is a metal, which is the sodium, and a nonmetal, which is the chlorine, plus the last thing is water. All right? So we're going to take advantage of this acid-base neutralization, this idea. And a lot of people will write acid-base reactions, neutralization reactions, as far as a net ionic reaction. Very simply this, going to H2O. All right? So that, when you see that right there, we're talking about neutralizing an acid. And really, we could go back and look at what's going on. The HCl is aqueous. The NaOH is aqueous. The NaCl right here is aqueous. The water's liquid. So canceling out the spectator ions, the chlorine would go, the sodium would go, and the sodium chloride would go, leaving behind the hydrogen hydroxide in the water. Okay, so neutralization reaction is going to look like that. There is a formula that will work to calculate neutralization, and it looks like this. Molarity of an acid times the volume of an acid will equal molarity of a base times volume of a base. And you've seen this equation before when we were talking about dilutions. It's the same idea. Really, you're stating the fact that here a mole of acid equals moles of base, which is exactly what is happening once you neutralize a acid-base reaction. But this will work, okay? Provided you're talking about monoprotic acids and only one hydroxy bases. But anyway, I'm going to solve this problem that I have written here. I got a beaker, contains 25 milliliters of a 0.315 molar solution of hydrochloric acid, and I'm going to try to determine how much, so what volume, of a 0.125 molar solution of NaOH is required to neutralize it. All right? So again, the basic equation, the net ionic equation, will be the acid plus the base going to water, H2O. So what I want to do is, I'm going to use, I'll use this one first off, this equation. Okay, I will. Molarity of acid, volume of the acid equals molarity of the base, volume of the base. So the molarity of the acid is 0.316 molar. The volume of the acid is 25 milliliters. I'm going to multiply those. That is going to equal the molarity of the base, which is 0.125 molar. And I'm going to now solve for the new volume, the volume of the base. So what it's going to end up being is, when I do it, 0.316 times 25 milliliters divided by 0.125. I'm going to get V, volume of the base, to be 63.2 milliliters. All right? So that's pretty simple, okay? And I could have done that, I could have figured that out in terms of moles first. So maybe I'll just kind of do this like half picture right about here. Let's just say I'm going back to what molarity is. Molarity is equal to moles over liters. Okay? So if I have the molarity of a acid as 0.316, and the volume of that acid is 25 milliliters, I could figure out what the number of moles are going to be of acid. So I'm going to first find the moles of the acid. All right? And it's going to be 0.316 molarity equals X moles over 0.025 liters. I'm putting that 25 milliliters into liters. All right, so solving that's 0.316 times 0.025 tells me I have 0.0079 moles of acid. Now the whole point of neutralization is that if I have this many moles of acid, that means I need to neutralize it with that many moles of base. That's the whole point, all right? Moles of base. So that's what's needed. I need that amount. Well, looking back at what the concentration of the base was, it was 0.125 molar, all right? So 0.125 molar is the molarity of the base equals, this is the number of moles that I need, 0.0079 moles. Now divided by X liters. Well, I'm going to come up with the same number. But when I do that, it's 0.0079 divided by 0.1225. I come up with X being equal to 0.0632 liters, which is the same answer that I got the first time around up here. Oops, whatever that is. Anyway, it's the same answer that I got in milliliters the way before. So try these. Right.